Okay. All right. Okay, right. So with this, I would like to open the lightning talk session. So the first talk is a remote talk. The other ones will be here in person. So Joshua, you have 5 minutes, and after that, we have like a couple of minutes, 3 minutes for 1 or 2 questions, and then go on to the next one. So take it away.
Great, thank you very much. So hi everyone, and good evening from Singapore. It's wonderful to be joining you all via Zoom. Okay, so since we don't have a lot of time, let's get to it. In this brief talk, I'm going to attempt to offer a plausible answer to the question of when scientific progress occurs within a field. And by a field, I mean something akin to a segment of science that is unified roughly by a disciplinary matrix or a paradigm in the broad Kuhnian sense. Okay, so when does scientific progress occur within a field so understood? Well, to begin, let's cover a few key ideas. So here are 3 different beliefs we might have. Our beliefs are the kinds of things I think that come in degrees. Hopefully that much is can be seen through these 3 examples that I've quickly got displayed here. What's more is I think there's good reason to believe that our beliefs should obey the axioms of probability theory. Or more exactly, there's good reason to believe that our degrees of belief should conform to the axioms of probability. Okay, then now let me introduce you to, or perhaps remind you of, Bayes' theorem. Since there are good reasons to believe that our degrees of belief should conform to the axioms of probability, and because Bayes' theorem is a deductive consequence of the axioms of probability, we have good reason to believe that our degrees of belief should conform to Bayes' theorem. What's neat about Bayes' theorem is that it tells us how we should update our beliefs about the world in light of evidence. Okay, now that I've introduced all of that, I can talk about the relationship between a hypothesis and some piece of evidence. Right? We say that some piece of evidence E confirms a hypothesis H when the probability of E given H is greater than the probability of H. Otherwise said, E confirms a hypothesis H when our posterior probability is greater than our prior probability. Or perhaps said in a third and perhaps even simpler way, a piece of evidence E confirms a hypothesis H when our confidence in the hypothesis is greater after having received the evidence than it was before we received the evidence. Okay, now here's something else that's neat about Bayes' theorem, right? If 2 people start out with very different but reasonable priors, right? That is that they start out with very different degrees of belief in some, say, hypothesis, then as more and more evidence comes in, their posterior probabilities in the hypothesis will, via Bayes' theorem, converge on one another. To put more simply, right, if 2 people start out with very different but reasonable beliefs about the world, and they update their beliefs in accordance with Bayes' theorem, then as more evidence comes in, they'll come to believe the same things roughly about the world. Okay, then, so let's now return to our question. When does scientific progress occur within a field? Well, I think we might say that scientific progress occurs within a field whenever there is an increase in the average degrees of belief among diverse members of the relevant scientific community, that is, the members of the field. If we think that our scientific theories are confirmed whenever there is an increase in degrees of belief of engaged scientists who begin with reasonable priors, and who update their beliefs, their degrees of belief in light of evidence in accordance with Bayes' theorem. And we think that confirmation is closely tied to a theory's truth, right? Then it seems reasonable to think that a scientific field makes progress towards truth whenever there is an increase in the average degrees of belief among diverse members of the scientific community. Now, the reason I'm including the requirement that there be diverse members within the field whose degrees of belief factor into a judgment about whether progress has been made is that by including them, hopefully, perhaps likely, will wash out the effects of biases and idiosyncrasies of individual scientists that might affect their judgments about, say, the value that they attach to the probability of some piece of evidence being true. Okay, so I'll end now by just repeating my takeaway answer to the question of when I think scientific progress occurs within a field. Scientific progress occurs within a field whenever there is an increase in the average degrees of belief among diverse members of the relevant scientific community. Okay then, thank you all very much for your kind attention.
Thank you very much. We have time for a couple of questions. I'm going to try and turn the camera so you actually see your audience. You do have quite a few people in this room. You're like this.
Oh, wow. Hey everyone.
There's more here. Yes.
Yeah, thanks so much. That was interesting. Could you maybe say something about how theory change would connect or does not connect to scientific progress? So when theories actually change, rather than our confidence increases in them?
Yeah, good question. I mean, I think this is kind of why, I mean, I guess I just wanted to, I guess, stick to talking about this kind of within this kind of paradigm sense. I mean, I guess, you know, I mean, when theory changes occur, I mean, you know, like a whole bunch of things like are up for grabs, you know, debates about fundamentals, what kind of is going to count as evidence, you know, and even kind of the epistemic values that we hold kind of can go out the window, right? Do we care about simplicity? Do we care about, you know, coherence? Do we care about a whole range of things? And so I'm not sure quite what I would want to say just yet, given what I've had today about, I guess, the sense in which we would make progress when what it is that we're doing is kind of, I guess, changing paradigms. You know, all of these things are up for grabs. I think more conservatively, all I want to say at the moment is here's perhaps what scientific progress would look like, provided that this kind of disciplinary measure, all of that kind of remains fixed. We've at least agreed on our epistemic values and perhaps, you know, what counts as evidence and, you know, what we consider to be the fundamental entities of the science that we're engaged in. So yeah, I mean, I think your question highlights like clearly the limitations of the account that I'm attempting to sketch here. Yeah.
One very quick question.
So if I understood it correctly, your basic measure was that confidence increases. And I was wondering if scientific progress can't equally be the opposite, that confidence in false theories decreases.
Yeah, I mean, I suspect you would likely you could likely sketch it out in those terms as well. I mean, I guess that, I mean, if it's the case that you know, evidence is going to count, is going to boost your credence in the belief in some particular hypothesis, and at the same time, it's going to be incompatible or undermine, you know, belief in some false hypothesis, then presumably your confidence in that, you know, hypothesis is getting lower, right? And so you would come to think of it as being less likely to be true or perhaps false. So my guess is that you could probably tell a similar story in those terms as well. I mean, yeah, which may be helpful because sometimes, I mean, maybe what it is that we're doing when we kind of conduct science is actually kind of ruling out certain hypotheses. So yeah, I mean, I think that may be an equivalent way of articulate in the project.
Okay, right. Then we're going to cut it at this point. Thank you very much. All right, then we're going to get over to our next one. I think Frank.
I think so.
Let me. This is your, these are your slides, right?
Yes.
Oh, it's because the. Sorry. Yes. Okay, that should be fine. Let me just adjust the
Can I
camera.
make this smaller? Is that okay?
Yeah. Yeah. Perfect.
And
Yes.
5 minutes of fame. So thanks for coming. This is joint work with Aran Arslan at Boğaziçi University. So I'll have to look at this and then at you at the same time. So claim is accepting Cohen's error rates of alpha beta 1/4 at the level of an individual researcher's contribution to scientific knowledge incurs long run negative academic consequences at the collective level, so for science as a whole. And this insight we claim is crucial to explain the sad state of scientific knowledge, particularly in behavioral science. And the key word is replication crisis. Although alpha over beta 1/4 can be reasonable, we should say, at the level of an individual scientist, it becomes unreasonable at the collective level. This is, sorry about this, this is Cohen. He says this originally in the 60s. This is from 88. So it's proposed here as a convention that if the investigator has no other basis for setting desired power value, which is the 1 minus beta error rate of then 0.80 BUs, that means beta is set to 20. This arbitrary but reasonable value is offered for several reasons. And then he refers to this other paper. And if you look it up, you don't really find the reasons. It's really circular, he says. Well, he doesn't say, but it is circular. But anyway, the chief among them, he said, as reasons is that takes into consideration that the implicit convention for alpha of 0.5, which is widely accepted already, then given this, the beta of 20 is chosen with the idea that the general relative seriousness of these two errors would be of the order of 0.20 over 0.4, i.e. that have 1 errors or alpha errors of the order of 4 times as serious as 2 errors. So that gives you this. If you put this in the metrics, this here is illustrated. This comes from Fiedler for the for judicial decision making. But notice here that setting an innocent free or letting a guilty go, you can either do one error or the other. Once you have probabilified it, you can commit both errors at the same time to different degrees. Anyways, you would say that this is the more important error to take care of. Yeah, so 4/1. This is we call the body of scientific knowledge. So people want to stick something in there, individual studies all the way up at some point, evidence hierarchy up as we get to meta-analysis. If you put in information that has preferentially reduced one error but not the other, then the claim is you can't get all the way to the top level of the hierarchy. At least once you stack there, you're on very shitty grounds in the first place. So you can get there because of that. That's the idea. Why? Because the replication probability of a true effect size is largely determined by the statistical test power, i.e. the 1 minus beta error rate of a true originally observed effect. So on the assumption that your original observation is the true effect, then I can tell you what the replication probability is, given you tell me what the sample size is, what your effect size is that you've observed, and what your alpha error is. So this implies test power of 0.80. In psychology, the best estimate is that median observed test power even only comes to 0.05. So that's I could stop here. Yes, that's unsurprising from here that there is a replication crisis. Why would this matter? Because generally what behavioral sciences observe are very small effects somewhere here. This is where clustering. And if you have these, then you have rather low heterogeneity, which means not so vast variance. Whereas everything that is slightly larger and could be more interesting, i.e. could be studied smaller samples, has high variance. You have to explain what's in there. Very difficult to do. And the same holds for replication studies. So typically we observe small effects, often so small that they're overlain by the standard measurement error, so you can't see much there. And that counts because if you want to study a small effect hard under error rates alpha beta the same 0.5, you need a big sample, and anything less will not do. 1 minute. Okay. So So this is epistemic considerations concern the identity of risk-related information that the body of scientific knowledge should include when an individual researcher contributes to the body of scientific knowledge. And the idea is that I individually, I can rely on you. You're going to fix my mistake, but I'm going to make sure that I'm not going to shout it for a false alarm. So I'm going to be really tight about alpha, but beta, well, I don't care so much. Maybe other people will. So that means if I'm tight about alpha, then I will likely not publish if my alpha goes beyond 0.5. But once it is below 0.5, but my beta stays somewhere lax, I will publish. And that means the publication will be full of stuff that cannot, probably not be replicated. So that's the consequence. If you provincially care about avoiding mistaken discoveries. And that's what happens. Yeah, but this, if you turn it around, it becomes problematic at the level of the collective knowledge. Because it implies the failure at the collective level to apply the best available statistical inference systems in service of generating scientific knowledge for which you require large samples and low error rates. And this was 5 minutes. Okay. And if replicability is the mark of trustworthy science, and it is, then what are exclusively academic considerations? Low test power can be seen as the main explanatory factor for the replication process. So Cohen's convention of 1/4 at least set the tone, i.e. made it acceptable that you have differential acceptance of differential preferences to reduce two errors in different ways. That was the thesis. Thank you very much.
Any questions or comments? Yes.
Yeah, so some journals have increased the requirements for power now, but only the most fancy journals can do it because of the big costs, right? So Nature Human Behavior for a registered report with 95% power. But yeah, for that journal, I'm willing to do the extra work. But otherwise, how do we get people to increase data? Because it's really a lot of extra work.
Yes, because we don't have theoretically informed measurement units, we tend to report standardized effect size measures. So we report the mean difference over standard deviation. The standard deviation is the pooled observed standard deviation. If you look into that, theoretically, you can throw out certain amounts of error. Okay, suddenly your effects grow. So at the same sample size, I will have more power, but it's a theoretically cleaned effect that I will report to you. So that's one way.
Okay, then we're gonna go into the next talk. Thank you very much. Yes. Oh yeah, good idea. Okay. Daylight.
Yes.
Yeah. Yeah, I think they were all old comments, but yeah. Okay. Yes, thank you.
Okay, so it will be a short talk about a long story with a quite dramatic title, Scientific Collaboration Under the Shadow of a War. And today, yesterday, it was 6 months since Russia invaded Ukraine. And of course, the main message is that it's strategy, but it has affected multiple areas of our life, including science. And the main story I would like to share is the story of integration and disintegration of scientific community. So we have endogenous and exogenous factors that influence these processes. And there are multiple endogenous factors, including progress in science, individual drivers, new disciplines, paradigms, so on and so on. But today I would like to factor on exogenous factors, namely on very controversial marriage between politics and science. I think it's reasonable to argue that most of the scientific endeavors are to some extent influenced by politics. The question remains, how porous is the membrane between politics and science? And the story of fusion community, especially the one in Europe, is an extreme case where influence of politics on scientific endeavors is extremely high. So is this fusion community have this original sin that it has been established by politics and it has been shaped by politicians. In the 50s, fusion research has been perceived as a tool not only to advance fusion research, but also as a tool to integrate Europe. And 6 European countries decided to build a community to advance this research. And decade by decade, more countries have been invited to join this community. And there was huge struggle to what extent this collaboration or unity should be. Countries like France or Italy pushed for total unification. So we have one fusion research program. We pool all the resources, and we are all striving for this one goal. Other countries like West Germany decided to keep some resources to the local community and only engage part of the resources. And it was regulated by politicians to the extent that, for example, in Germany said that, oh, we will devote 45% of our fusion resources to this international collaboration. Some other countries decided to engage 100%. So this fusion community is quite well-crafted community, to be honest, because it has been decided on a central level that institutions will collaborate, how much resources they are going to get. And Russia has been a significant member of this community since the late 70s, and it is well embedded in this whole community network. And six months ago, they decided to invade Ukraine, and scientific community, at least in Europe, decided that that's not something that we agree and we can tolerate. And multiple organizations, including ERC and many fusion institutions, said, no, we are cutting all ties to Russia. We are not prolonging this collaboration. Including Jülich Center, which is the main fusion research center in Europe, Italian and French fusion research. Some fusion research also stopped because central funding bodies decided to cut all the ties. Other countries like India and China took a very different route and said, yes, we do welcome Russian scientists. So there was also much politics involved. And we still don't have data to say what is going to happen. But based on historical data, we can expect that the fusion community will disintegrate and disintegrate into multiple sub-communities. And we will be able to observe communities around Asia, North America, and Europe. And Russia, despite this inviting talks of Asian powers, will align more with the US fusion community than with Asian communities. And that's it. Thank you.
To comments, questions? Yes.
Yeah, so thanks for your talk. And this is really just a comment that I think this is a tragic but also really fascinating natural experiment that we're seeing being run here, and how, like, in real time, to watch the evolution and disintegration of communities. So I think it's kind of cool.
Yeah, thanks. Just briefly, the prediction almost, yeah, that Russia would align more closely with America than with Asia is based on what consideration? Did I get it right?
Yeah, yes, that's a collaboration. These are collaboration networks just before the invasion from 2 years. And if we remove all the ties between institutions that decided to cut ties with Russia, we will end up with this disintegrated community. So these are historical data because we can't see the effect of invasion, but probably we can expect something like that.
There's one last question.
I just wanted to know that back last year in the summer, Russia issued a new law that stopped researchers from being able to gather survey data without approval from the government, which meant at the time we were running the COVID stress study that we had to cut data collection prematurely. And that meant in the future it would become more difficult to collect data in Russia. And also looking at that and various other restrictions on free speech and research practices and grants that were issued all at the same time under the cloud of COVID. It's quite scary. When I saw this, I felt quite a lot of sympathy for what's going on for Russian researchers at this moment.
Yes, probably, but this fusion community is actually quite unique because it's very close to Putin's heart. There is one. And he personally oversight fusion project, and also those ties, in contrast to social sciences and everything related to social sciences, these are long-lasting ties. They lasted for 50 years, and Russia was in the center of fusion community. So also the position of the fusion community compared to other sciences is different and unique. So, thank you.
Thank you again. Then we're gonna. Oh yeah, it's about. No. Okay.
Like this. Yeah. Hi everyone. So in the next 5 minutes, I'm going to try and go into a topic that is not very controversial and not at all ambiguous, which is diversity. So please bear with me as we go through that. But very quickly, to set the stage, much of our work in science really is skewed towards one section of the world's population, which is pretty much the West. And in this visual, in this cartogram, I tried to resize the world map based on the world's population using UN data. And naturally, this is just one segment of the world's population, which is adolescents. But you can really nicely see how and where the majority of the world's population lies, vis-a-vis majority of the world's science is done. Now, naturally, the question is, who is the science serving? And as we are in the field of the science of science and really thinking about the last 10 years, we've thought so deeply about replicability and reproducibility. And I just want to add the fact that we're neglecting millions and billions of people from the science as one other additional feature that might sort of open doors as we start to think about the future of science. But really, just to sort of go back a little bit and really think about sample diversity and diversity in science. We often, as scientists, at least in social behavior sciences, but also biomedical sciences, take a slice of the world's population to draw meaningful inferences, and naturally we can't really possibly conduct research on billions of people, so we draw a sample. Now, to draw these samples, we often rely on some sort of taxonomies, in taxonomies that make sense for us. Now, in thinking about diversity taxonomies, one thing that's been really helpful for the way I think about it is our preference for lumping versus splitting samples. And this is a great editorial by Jeremy Berg, who was the last director of NIH, who uses this really clever analogy, which I'm going to try not to butcher, where he says that actually, if you try and study cancer cells, if you lump them too much to the degree that you try and study them, say by their tissue of origin, then you might obscure very important biological differences, versus if you go on splitting to the other extreme, you might yield n=1, or like really go into that sort of nuances where it might not be statistically viable. So really, what is the trade-off between too much lumping and too much splitting? And one thing that I think is particularly relevant in psychological and behavior sciences is whether there is too much lumping. And of course, this is in the context of the famous WEIRD acronym, which stands for Western Educated, Rich, Industrialized Communities. And the main message here is that while the acronym and is really powerful in highlighting and articulating how not only our science is skewed, but what our science relies on, that small section of population, is actually peculiar and weird, but also the fact that today these sort of dichotomies are no more relevant because there are pockets of weirdness in non-weird countries, so rich people in India versus pockets of non-weirdness in Western countries, indigenous populations in Canada, and so on. So how can we start thinking about sample diversity from a more constructive sort of frame? And I really like, again, going back to lumping and splitting on sort of a spectrum. So we are currently here, which is really this macro, really large Western versus non-Western, but can we go a step further and really think more deeply about between and within country diversity? And I'll just show you a graph in a second, but really ultimately, can we start to really granularly pick up on these interpopulation versus intrapopulation differences? And actually that might take us a long time, but where can we go from that? And just to show you an example of how we've tried to operationalize sample diversity is look at where the literature sits. And I know the graphs are not very visible, but really thinking about sort of how the world is just, how the science is really skewed towards a certain segment of the population, whereas where the rest of the world lives, but really thinking about within region diversity. So what is the population demographic, and how do we really collect these samples? Are they representative? Are they disadvantaged? Are they convenient? That tells us a lot about within country diversity, because it's not that the problem is just that we're missing billions of people living in the global south, but we're also not thinking very deeply about diversity that sits and exists within global north, that is UK, US, and so on. And finally, there's intersectionality. Human diversity is really complicated. We can come up with more categories as we can imagine, and surely certainly in this room. And finally, I just want to end with saying that diversity, as we know, is really sort of very skewed towards a perspective that we relate to in the Western context. I grew up in India, very different social identities that I grew up with, caste, religion, of course, gender, that is common. And surely, like that, similarly, other parts of the world might have different marginalized identities, different conceptions of diversity. So how can we start to sort of build that repertoire, or like that, expand the definition of diversity, if you will? And we cannot do that without the help of researcher diversity, and without the help of researchers who live and do research in this context to really join and weigh in the conversation. So I don't know if I've already made my time, but I'll stop.
Right, any questions, comments from this one? Yeah.
Yeah, thanks for the stuff. I think this is a good example of where currently consensus about diversity is really in the wrong direction in psychology. Yeah. Because exactly as you say, I mean, this makes sense to think about, like, what are we really studying? What you see now is that there's this sort of consensus that if you just run your study in 74 countries, you can get basically into science because you did a lot of work. Good for you, you get a science paper out of it. But then they do it in 74 university campuses, Whereas the diversity is greater if I use the neighborhood behind me in order
Absolutely.
and the neighborhood on the other side of the road, because they're rich and poor people and they differ much more than all those 74 students. So I hope you write a very nice comment in science about all these papers.
So actually, it's just if I can quickly respond to that, it's really quite timely that you say this, because I think a lot of these large-scale studies, and I was going to ask you that question, which is, you know, mask or give the illusion of sort of progress, because you know there are larger samples, but actually if you look under the hood, there is lack of within region diversity. So, and you know, in a country like India with 1 billion people, of 60% living in rural, and if you sample, you know, 100 people in a university, that's really not representative of Indians, let alone urban, rural, and all of that. So yeah, that's definitely a big blind spot. Yeah. Thank you.
Yeah, okay, great. Thank you very much. The last lightning talk of the day. Oh wait, I could actually keep sharing. This is the link that I got out of this. Wait, where are we?
Did you get it? I don't see it.
No, there's some.
Yep.
So.
Cool. So I want to talk about academic publication. I'm a PhD student in the field of machine learning, which just declared a crisis. Did my master's degree in psychology in 2013, 2 years after they declared a crisis. And in all these conversations, the thing that constantly stuck in my mind was academic publication, our currency as professionals, and how maybe in order to like sort of import some of the lessons that we might have gotten from the replication crisis, we might have to think a bit more revolutionary, let's say, not just in terms of the publication machine, but maybe also in terms of how we think about what our academic outputs are. A lot of cool stuff has come out in recent years, and I think it has a very inspiring sort of, I don't know, future perspective on what science could be, collaborative and open and transparent and immediately reproducible. But still, it seems to me that in 2022, if I want to have an academic career, I got to get my PDF in the right place. And this drives me bananas, because in my field, the PDF is a tiny piece of a very, very, very deep glacier. I got all sorts of bits and pieces in my projects, and sharing them is not enough. I got to have them working and reproducible in order for it to be useful to somebody else. But the time I take to make them reproducible, I'm not cranking out that next PDF that's going to get me the job that I want. I am inspired very much by open source software and the sort of things that I think could be accomplished if we think a little bit more like that. If we think about our outputs being portable so that the next person can pick them up right where we leave off, so that we can ingest contributions, both large and small, to create, at its best, some really kick-ass stuff. The centerpiece of which is this thing called Git, which I'll talk about a little bit more in a minute. So here's what I did. I kind of synthesized, I grabbed a bunch of ideas, none of which were mine, but that I thought were really cool, and all the stuff that I was reading, and I tried to synthesize them into some kind of knowledge platform. Think if Wikipedia and this thing called Git had a baby. I then took these ideas and I presented them to my supervisor and to a handful of rather motivated software students who talked with me about what was possible and made design decisions of their own. As part of an ongoing project, they took the first steps towards some sort of proof of concept. I have no idea how right we are about this stuff, but maybe we don't have to be right. Maybe what we ought to do is be willing to fail loudly and honestly and openly. Cunningham says the quickest way to a right answer is to post the wrong answer on the internet. Here is our wrong answer on the internet. It's open source, so take what you like. If you have your own idea, that's better. But we take that a step further and walk into spaces like this to talk about the decisions that we've made, because maybe you have a better idea and we can jam on a better solution. Here's a whirlwind of stuff that I would like to talk to you guys about really quick. Consider the idea of a living article. Imagine a constantly current systematic review with lots and lots and lots of contributors that sort of highlights ambiguities and research opportunities. Imagine now the research opportunities become empirical papers that are, surprise, surprise, actually reproducible and include all of the things and are not just focused at the PDF that sits at the top. Imagine also decomposing these empirical projects So you get peer review at every step of the process and not just at the end of it. Also, so that you could pick reviewers that might be experts in the specific sections of your paper and not just the paper as a whole. And also so that, what is the thing? Pre-registration, not pre-registered, registered reporting is baked into the process, that it's always present. And more importantly, so that you can have spontaneous collaboration. Somebody's got a better method than you maybe, or maybe they spontaneously decide to contribute data to whatever it is that your published method is. We can also talk about actually paying reviewers. I think that would be rad. And maybe having contributor roles being part of the publication itself, possibly visualizing it as a rad dashboard. We can talk about that. All right, so what did the students actually do? They took the first steps towards a proof of concept. They built it on this thing called Git. It's a kind of technology that software engineers use to massively collaborate. The students know how it works a lot better than me, so I won't go too deep into it, except to say they built a front end for it because it's a pain in the ass to use if you don't code. What you can do at the moment is browse articles, view them in plain text, and of course contribute, and interact with them in different ways. You can leave comments, or if you decide you want to contribute, you can copy the entire project and either make your adjustments in plain text or download it into whatever your workflow is, make your adjustments, and then upload it and suggest it for some kind of review. And you have a way to sort of immediately view what the different versions are as it progresses. I'll leave you with one last thought, and that's this. I'm not hating on the PDF. It was pretty cool, but it was released by Adobe in 1992, which was the same time that Guns N' Roses had music on the radio. Some of you may be upset to learn that that was 30 years ago. Now, I'm not hating on Guns N' Roses. It's pretty rad, but in 1992, we also had Rage Against the Machine. All right, thank you. Do I have time for questions?
Yeah, absolutely.
Yeah, all right.
Anyone?
Oh, I just want to say how I love this, like, really love this. Yeah.
Thank you. Some of the students are here, by the way, so be sure to catch them at the poster because they can explain the Git thing that I cannot.
Is that a dinosaur in the QR code?
It is a dinosaur in the QR. They also, by the way, they also came up with a logo, which I think is adorable as hell. Yes, sir.
Thanks, Andrew. I love this, and I need to talk to you more. It's really connects to my own work. Where do you, right now you have kind of like a more user-friendly front end to Git, let's say.
Yeah, actually,
where
exactly.
do you envision sort of this developing more as you sort of like emendate on the space model? Like what directions are you considering?
So I think there are inevitably some research areas that would benefit from a different kind of publication model. In mine, where I'm doing ground truthing for machine learning, for certain kinds of projects where there's like a lot of ambiguity, it's inevitable that we're going to need to collaborate if we're going to gather the data on these things. Like one university lab is not going to cut it. And I don't want to leave all that up to Google and Facebook and whatever. So I think for certain research areas, like a platform where you could sort of collaborate massively without like a lot of micromanagement is just going to be useful. So I don't know, my plan is to kind of pitch it to DU Delft, see if they'll sort of own it a little bit and develop it, at least for, yeah, the areas that I think will be useful, and just kind of see where it goes from there. But yeah, I mean, this was a moonshot. And yeah, I have no idea if it's going to pan out.
I'm curious. So the idea of the post PDF living publication. So how do you imagine kind of like the mixture of like authorship and like signeeship, like kind of fits in that the context of that thing. So you contribute something, you may review it and sign it. Yeah, I mean, like what levels of contribution are there and visible and available to both kind of on the one hand incentivize activity, but also kind of assess its kind of ongoing activity, like a review, as you kind of talked about earlier.
Yeah, so the first thing I would say is the contributor roles taxonomy is really fine-grained, and I think can be automated in such a way that you can visualize it very nicely. So rather than having a list of citations with your name somewhere in the author list, you can very easily explain or more easily explain what sort of things it is that you typically do and what you've contributed to. And I'm not sure how to integrate reviewing, but I really do think reviewing should be a part of that.
Yeah.
The fact that it's silent and all this drives me kind of bananas too, because sometimes I want to read it and know about it. And in terms of incentivizing activity, yeah, I don't know. Like I thought we just start paying people for their labor, like review not just as a service, but you're putting your time into it. So many PhD students are struggling. Why not give it to them instead of the $19 billion industry? So yeah, that's my best idea now. I know it's not perfect, but I feel like, yeah, there's one more caveat to all this, and it does disproportionately benefit, I think, certain people. So like people that typically end up as middle authors, statisticians that jump in on projects, but like didn't really come up with it, and they're not the head of a research lab or something. I think something like this might benefit them more than, I don't know, maybe somebody that ends up in a PhD, like cranking out an handful of first author papers. I don't know. I'm not smart enough to have all the answers, but again, that's why I'm kind of putting it out there.
Thanks.
Yeah, I think any remaining questions, let's discuss them. You can discuss them in person right now. So we have 15 minutes until we wanted to start the plenary discussion at the end, and also bring up anything that came up here in that session, of course. So thanks to all the presenters. That was